Okay, remember what we need to find the derivative of an inverse. So we have our original function. We're going to have to find the derivative of that function, and we're going to have to find the inverse function. So if we find the derivative of this function, the first thing we're going to do is rewrite that with a fractional exponent. So x subtract 2 to the 1/3. And now when we find the derivative, the 1/3 will come down in front. And then when we subtract 1, that will be a negative 2/3. So then the negative 2/3 brings the fraction to the denominator. And here we have our inverse, our derivative function. Right? I guess I didn't need to write that right there. So there's our derivative. All right, now we're going to find our inverse function. So if we rewrite that as y and swap the x's and the y's, well, the only way to cancel something that's being cubed is to cube it. And then those cancel. And then we cube that side. So x cubed is equal to y subtract 2. So now we're going to add 2 to both sides. So x cubed plus 2 is the inverse function. So I'm going to write that here. F to the raised negative 1 of x is equal to x cubed plus 2. Okay. So now we just take the formula up here and write, so the derivative of the inverse is equal to 1 over, then you take the derivative, the derivative, there's another fraction, so 1 over 3 x subtract 2, so I'm going to put that in a big parenthesis, big parentheses to the 2/3, and that's x subtract 2. But where that x was, goes the inverse. So x cubed plus 2. Well, look at what we have inside those parentheses. Here we have a plus 2 and a subtract 2. Those cancel. So now we have an x cubed to the 2/3. Well, what do you do when you raise a power to a power? You multiply those exponents. So that becomes 3 times 2/3 is 6/3. 6/3 is the same as x squared. So now all of this becomes 1 over 3x squared. And then when you multiply by the reciprocal, you get f to the raised negative 1. The derivative of the inverse is 3x squared. All right, let's see. And then sometimes you're going to have functions that without a computer, you can't really find the inverse very effectively. So what we're going to do here is we're going to say that the inverse function, because I know that something this complex, we can't find the inverse, so I'm going to say the inverse, I'm going to call that inverse function y. Now we can still find the derivative. The derivative of a polynomial is easy. So that is 15 x to the 4th plus 1. All right? So now the derivative of the inverse is 1 over 15 x to the 4th plus 1. And inside that x goes y. So I didn't really need to spread that out so far. So yeah, on these, it's actually pretty easy. This right here is the answer to that. All right, that's it for this one.